Good morning, everyone. I am A Krishna from second year mechanical. Today, I'm going to present you about functions and efficiency of a draft tube, which is an important term or study or topic which we study in fluid machines and hydraulic machines. Let us see the introduction of a draft tube. A draft tube is a crucial component in hydraulic machines, primarily used in turbines. As we already said, it is a very important one. It connects the turbine outlet to the taillights, allowing for the controlled flow of water. Understanding draft tube is essential for improving the efficiency of a hydraulic system. Generally, we don't get much efficiency in hydraulics because uh, we get several losses like friction loss, minor losses, contraction losses. Due to all this, we get less efficiency, but by using draft tube, we can improve the efficiency of a hydraulic. The purpose of a draft tube. The purpose of a draft tube is to recover kinetic energy from the fluid exiting the turbine. It helps converts this kinetic energy into pressure energy, increasing overall efficiency. Additionally, draft tubes mitigate the turbulence created by the water exiting the turbine. No, we can see the picture. The use of draft tube in reaction turbine is to reduce or velocity or kinetic energy of a motor making exit. While at the exit, the water leaving will have some velocity or kinetic energy. To reduce that is the main function of draft tube, because to convert the kinetic energy into pressure energy, allowing turbine to install above tail pull level. Types of draft tubes. There are several types of draft tubes including straight, elbow and conical design. Each design has unique flow characteristics and efficiency profiles. The choice of draft tube depends on specific hydraulic conditions and turbine design. Here we can see a picture. The cold water in, the cooling field, the water distillation, drift eliminators. Hydraulic efficiency. Draft tube enhance hydraulic efficiency by reducing energy losses in the system. They help maintain a smooth flow of water, minimizing turbulence and cavitation risk. A well-designed draft tube can be significantly improve the overall performance of a turbine. No, this is a draft tube seen here. The outlet section, the draft tube pipe, draft tube inlet section, draft tube elbow. Energy recovery. The energy recovery function of a draft tube is vital for maximizing output in hydroelectric plants. By converting kinetic energy into pressure, it contributes to the system net energy gain. This energy recovery is essential for the economic viability of hydroelectric projects. Tailless inlet of draft tube. Flow characteristics of a draft tube. The design of a draft tube influences the flow characteristics of the water moving through it. A well-optimized draft tube will promote laminar flow, reducing energy dissipation. Understanding flow patterns help engineers design more efficient draft tubes. Impact of geometry. The geometry of a draft tube plays a significant role in its efficiency and performance. Changes in diameter, length, and curvature affect how energy is recovered from the fluid. Engineers often use computational fluid dynamics, can be termed as CFD, to optimize draft tube designs. Cavitation considerations. The cavitation is a critical concern in draft tube design as it can lead to damage and inefficiency. Proper design and material selection can mitigate the risk of cavitation occurring. Monitoring and maintenance are crucial to ensure the draft tube operates efficiently over time. Let's see a case study on draft tube. Several case studies demonstrate the impact of draft tube design on turbine efficiency. For example, modification in the draft tube of a hydro facility led to a significant increase in output. Analyzing these cases helps inform best practices for future turbine installations. The conclusion and future trends we're going to see in draft tube. In conclusion, draft tubes are essential for optimizing the performance of hydraulic machines. As we discussed from starting, the main advantage is we can improve the hydraulic efficiency. Ongoing research and advancements in materials and design techniques promise further efficiency gains. The future of draft tube technology will focus on enhancing energy recovery and reducing environmental impact. The future will make it a full test search possible in remote web directions. Abstracts can be fetched. These are all conclusions on future work of a draft tube. But with this, I'm ending this session. Thanks Thanks to my HOD sir and my coordinate faculty to giving me this such a wonderful opportunity. Thank you, everyone.